In this video, I'm going to go through a few examples of how to balance chemical equations. But first, let's remember why we have to balance the equations. And that's because of the conservation of matter. And so the number of atoms of each element in the reactants must be equal to the number of atoms of each element in the products. Any element in the reactants must also be in the products and vice versa. And any element not in the reactants cannot be in the products and vice versa. And all compounds present must obey the rules discussed in earlier videos. So for instance, ionic compounds must balance the charges. That means if we have something like magnesium chloride, it has to be MgCl2. It can't be MgCl3 or MgCl or anything like that. So we have to use the rules for balancing charges on ionic compounds. And similarly, covalent compounds that satisfy the octet rule must have their octet rule satisfied, and anything that does not obey the octet rule must follow the rule that they can't have more bonds than what the neutral atom has in valence electrons. Essentially what this means is when we're balancing the equations, we cannot change the subscripts on things. So equations are balanced by changing only the coefficients and not the subscripts. Because if we change the subscripts, then we would be disobeying the rules that we established in previous videos about how these different compounds exist. And so let's look at our first batch of chemical equations here. If you want to pause the video and try balancing these on your own, I would encourage that, but I am going to go through these first three here in some detail so we can see how we can balance these. So let's look at this first one here. We have magnesium plus silver nitrate becoming magnesium nitrate plus silver. So the first thing we can do, we see have one magnesium in the reactants, one in the products, and that means those two are balanced there. Then we can look at something like the nitrates where we have one in the reactants and two in the products here. So that means those are unbalanced. Those are not yet balanced. And one thing you'll notice here, I'm looking at these as polyatomic ions. You can break these down into their individual atoms if you want to try to balance it that way, but if you can recognize when we have polyatomic ions, you can balance these by just counting the number of polyatomic ions. So that's the way I'm going to do it here. So these are not yet balanced, so what we can do, put a 2 in front of that silver nitrate, and so what that does is we end up now with 2 nitrates in the reactants, which means that the nitrates are now balanced in this reaction. But we see that we now have 2 silvers here and 1 silver over here, so that means these are unbalanced. So what we can do, put a 2 in front of that silver, and so that will make these now balanced. And so what we see, we have 1 magnesium in both the reactants and products, 2 silvers in both the reactants and products, 2 nitrates in both the reactants and products, and that means that this reaction is balanced. So let's take a look at our second one here. So we have potassium sulfate plus barium chloride becoming barium sulfate plus potassium chloride. So we have 2 potassiums over here and 1 potassium over here. That means these are unbalanced. We put a 2 in front of there, and that will make it so that these are balanced. We can look at the next thing here. So we have 1 sulfate here and 1 sulfate here. So those are already balanced. We have 1 barium here and 1 barium here. So those are already balanced. And we have 2 chlorides here and 2 chlorides over here. And so those are balanced. So we see we now have 2 potassiums, 1 sulfate, 1 barium, and 2 chlorides. And so that means that the reaction is now balanced. If we look at the next one, we see we have this iron 3 oxide plus carbon monoxide becoming iron and carbon dioxide. So we have 2 iron here and 1 iron here. Those are unbalanced. We put a 2 in front of that iron there, and that will make it so that these are now balanced. We have 3 plus 1 oxygen here, so 4 oxygen total, and 2 oxygen here. So those are unbalanced. We put a 2 in front of that carbon dioxide in the products, so that now we have 4 oxygens in the reactants and 4 in the products. But now we see that we have 1 carbon here and 2 carbons here, so those are unbalanced. We put a 2 in front of the carbon monoxide. That makes it so we have 2 carbons here. But now we see, having done that, we now have 5 carbons in the reactants, while we still only have 4 in the products. So that means these are now unbalanced. So what we can do, we just increment those carbon monoxide and carbon dioxide up by 1 because we know we have to keep the carbon balanced. And when we do that, what we see is we now have 6 oxygens in the reactants and 6 oxygens in the products. That means these are now balanced. Let's look at what we have here. We have 2 irons in both the reactants and products. We have 3 carbons in both the reactants and products, 6 oxygens in both the reactants and products, and so that means this reaction is now balanced. Now let's take a look at a new batch of equations here that we can try to balance. Again, if you want to pause and try this on your own first, I would encourage you to do that, but we will go through these 3 in some detail again. The first one, we have this arsenic sulfide here plus oxygen gas. That's becoming this arsenic oxide plus this sulfur dioxide gas. So the first thing we have is 4 arsenic here, 4 arsenic here. So these are balanced already. The next thing we can look at, we have 6 sulfur here, but only 1 here, so those are not balanced yet. We put a 6 in front of that sulfur dioxide. That makes it so that this is now balanced. We have 6 sulfur in the reactants and 6 in the products. The next thing we want to look at is the oxygen. We have 2 oxygen here, 18 oxygens over in the products. So to get 18 in the reactants, we can just put a 9 in front of that, and that will get us to our 18 oxygens in the reactants. And so that means these are balanced. So let's look at what we have here. We have 4 arsenic in both the reactants and products, 6 sulfur in both the reactants and products, 18 oxygens in both the reactants and products. Therefore, we have a balanced chemical equation here. Let's take a look at our next equation here. So we have this boron trichloride plus water becoming this boric acid plus hydrochloric acid. And so the first thing we can do, we see we have 1 boron here and 1 boron here. Those are balanced. We have 3 chlorides over here and only 1 over here. So those are unbalanced. We put a 3 in front of that HCl. That will balance out our chlorides here. So now the chlorides are balanced. We have 2 hydrogen here and we have 6 hydrogen in the products. That means these are unbalanced. We put a 3 in front of that water and that will give us the 6 hydrogens in the reactants. So now we see we have 1 boron in both the products and reactants, 3 chlorides, 6 hydrogens, and 3 oxygens. That means that these are balanced now. Then our third one here, we have barium chloride plus aluminum sulfate becoming barium sulfate plus aluminum chloride. So we have 1 barium here, 1 barium here. These are balanced right now. 2 chlorides here and 3 chlorides there, so those are unbalanced. We can put a 3 in front of the barium chloride and a 2 in front of the aluminum chloride, and that will give us the 6 chlorides in both the reactants and the products here. We now see we have 3 bariums here and only 1 here, so those are unbalanced now. So we put a 3 in front of the barium sulfate in the products. That'll give us 3 bariums in both the reactants and in the products. So we now have 3 barium, 6 chloride, 2 aluminum, and 3 sulfate in both the reactants and the products. So these are now balanced chemical equations. And so that was balancing these 3 equations here. So these are the practice questions. I would encourage you to stop the video and try these on your own before watching when I give the answers. I'm not going to go through these ones in as much detail. I'm just going to give the answers. So again, I would encourage you to pause the video and try it on your own. So for the first one, we have the sulfuric acid plus aluminum, and that's becoming aluminum sulfate and hydrogen gas. And when we balance it, we should get a 3, a 2, a 1, and a 3. The next one, we have methane plus oxygen gas becoming carbon dioxide and water. To balance that, we put a 2 in front of the oxygen and in front of the water. The next one, we have potassium phosphate plus magnesium chloride becoming potassium chloride plus magnesium phosphate. So to balance this one, we put a 2 in front of the potassium phosphate, a 3 in front of the magnesium chloride, a 6 in front of the potassium chloride, and nothing in front of the magnesium phosphate. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.